Problem I'm having is like, I have some acidity issues. So just after eating, for few minutes, I'll be coughing a little bit. Hopefully it'll be okay in a few days. So don't worry if I'm coughing a little bit, don't have to worry about it. So let's see. Okay, so I asked you to, solve the problems. So I think we completed.
You told us to do 33, 36, 35, 34.
Okay, any problems which you didn't get the answer?
I'm not sure. I have to count.
Okay. Anyone else? Any problems which you tried but it's not able to solve? So maybe I thought of doing some few problems from this page. This one is very easy, just like your, R is equal to mg minus a g plus a, things like that. So you can do it yourself. This one, the concept is given in the handbook. The reaction of the partition, the reaction of the partition. Okay, so which is this one? I think they mean the wall is the partition. Reaction forces between A and B, which is this one. What happens when the wall is removed? Does the answer to B change? So when the wall is removed, then it will start moving, changing the bodies are in motion. So let's try this. Did you do this, anybody? Anybody got this done? So that means this and this will be equal to 100 Newton. So that means if this and this are equal, this will become equal to 200. Since it's not moving, right? The friction can be ignored, I think. So I don't have to worry about the friction. So since this and this are equal, F A to B will also be 200 Newton. If this is 200, right? So if I take the free body diagram of the second one, so if you say this is if you say this is 200, this is also 200, which means this is 200 means this will also be 200. So let's see what else they asked. What happens between A and B? So between A and B, we already calculated this. B to A to B. So that's your action and reaction. What is the reaction of the partition? Partition will be 200 Newton. Okay, so what happens when the wall is removed? When the wall is removed, this entire block will start moving, right? In that case, the friction should also be considered, because in this case, I did not consider friction because the blocks are not moving. But if it starts moving, then things will be slightly different. So take it down properly. Mu is 0.15. N is 5 kg, 50. So the entire thing will be accelerating with certain acceleration value A. Anybody not following this? Why there is no force here? Because there is no wall, which means there is no contact force here. Don't make the mistake of writing this as 200 because it's not 200 now. Most important formula in mechanics. Mass is 5 kg, acceleration. So this will be one equation. Positive direction, this is negative direction. Mass of this is 10 kg, here the mass was 5 kg. Both will be moving in the same direction, acceleration A. Any doubts here? After that, it's simple mathematics. So I'm going to leave it to you. So solve this, you'll get the answer. Okay. So if you don't know how to solve this, then it means 10th standard, you don't know how to solve this. Only thing you should remember that this and this are opposite direction, FAB and FBA. So, but it's equal and opposite, which means FAB can be written as minus FBA. If I add this and this, I can change the signs. So this will become plus, minus. So if I add 1 and 2, this and this will cancel. So 215 minus 7.5 is plus 7.5. 200 plus 7.5 is 207.5. Minus 5A. I'm getting acceleration negative. How is that? Something wrong here? Am I doing anything wrong? Anybody? Acceleration I'm supposed to get positive. B to A is negative, okay. If A to B is positive, okay. Minus 15 minus 7.5, 200 is positive, okay. Everything looks good. Anybody? Any mistakes which I'm doing here? Yes, yes. So this is correct. Plus here 15. minus 5a. If I add this and this, I will be getting minus 5a plus 7.5 plus 7.5 is, so this will cancel. So towards 7.5. What is the mistake I'm doing? Okay, the mistake I may be doing is the direction. So the very reason why I put a minus here is because it's in this direction. And this one is positive direction. So that's why this is taken positive, whereas this one is taken in the negative direction. So that means this is already, so if this force value is x, this force value is also x, which means this is x. So the minus is already taken. So I think I made a mistake here. So this is x here. So since I put a minus already, I don't have to again put this minus here. So that means this is again x. I want to find the force. So force and acceleration. This and this will cancel. So 200, how much is that? Minus 22.5. So minus 22.5 from 200 will be, anybody? 78. So 178.
Is equal to minus 4.5. So we need to add, sir, the minus now. Sorry.
Okay. Is this correct? 178.5, 22.5. Yeah, 22.5 or 177.5. Is that right? Divided by 15. So how much are you getting? 177.5 divided by 15. Approximately 117, 125.1 something. 95. So
11.8, sir.
27 means it will be 1.8.
11.8.
That's the acceleration. If I substitute in this equation, I'll get the force. So force you calculate it yourself. Okay. So FBA or FAB. I think you should be getting something around 133.3 Newton, something like this. I'll double check it. Any questions? Any doubts? So the important thing to note here is when it is not moving, no friction. When it starts moving, the friction should also be considered. Okay. Anybody tried 35, 36? Somebody tried it? That's very depressing for me. At least if you say, sir, I tried it, but I didn't get the answer, means I'll be happy. You don't even open the book and try it. Thirty-seventh sum you want. Why 37th sum? Disk. Okay. Yeah, we'll come to 37. Let's finish this quickly. Did you get this 35? Okay. Block of mass 15 kg is placed on a long trolley. Coefficient of static friction between the block and the trolley is 0.18. So there is a long trolley. kg block. It's placed on a long trolley. The coefficient of static friction is mu is equal to trolley accelerates from rest with 0.5 meter per second square. For 20 seconds. Then moves with the uniform velocity. Discuss the motion of the block as viewed by a stationary observer on the ground, an observer moving with the trolley. So let's see. I know that if the car is starting very quickly, accelerating, I will get pushed backwards, which means there is an acceleration, pseudo acceleration. So if this is going at 0.5, this will also be 0.5. I know that if the block is trying to move backwards, the friction will be acting forward. So the friction is what is keeping the pen and the paper together. Similarly, the block and the trolley. So F friction is equal to mu into N. Mu is 0.18. N is normal reaction 150. Okay. So this will be the maximum force. So F friction maximum. Beyond that, it will not be able to push it this way. Okay. So F here, the pseudo force, F pseudo is equal to mass into acceleration. So mass is 15 kg, acceleration is 0.5, which means this will be 75. So 7.5 Newton. This will be 1.8 into 15. Anybody, can you tell me what is 1.8 into 15? $27. So up to 27 Newton, right? It will be able to go along with this trolley. So the pseudo force is only 7.5, which means it's not going to get pushed. Sorry, it's not going to get pushed backwards because the friction is sufficient enough to go this way. Any questions here? So take it down. So discuss the motion of the block as viewed by the stationary observer on the ground, an observer moving with the trolley. So if a guy is standing here inside the trolley, this block is stationary. It's something like, you're sitting in a train coach. So if there is a block, it is stationary with respect to you. But with respect to a stationary observer outside the trolley, this is going at the same speed as this one. So that means the block will be accelerating just like this one for 20 seconds, and then it will be going at a constant speed for a stationary observer. That's all. Any questions? This is your stationary observer. So you should say that just like the trolley, same as trolley, it will be going forward along with the trolley. Anybody not following this, please ask me. How come there is 7.5 Newton acting backwards? Then how come it's not going backwards? Nobody is awake. If anybody wants me to continue the class, you can answer. Otherwise, I will stop here. I can go back and take
Sir,
some.
it is because the block is it is because of friction, sir.
Yeah, that's all. So the friction is more than this force, which means the friction is, holding the block along with the trolley. That's all. As simple as that. Okay. Remember, when I ask a question, if nobody is answering, which means nobody is not, interested in the class. So I stop and go home. That's all. I mean, close the meeting. Okay, let's see. You wanted me to do 37.
37.
Disk revolves with the speed of 33 by 3. So let's say that's a disk. It is revolving with 33 rev per minute. Has a radius of 15 centimeters. Two coins are placed at 4 centimeter and 14 centimeter away. So one is at 4 centimeter, and one is at 14 centimeter. From the center of the record. If the coefficient of friction between the coins and the record is 0.15, static friction, which of the coins will revolve with the record? So listen carefully, very, very easy and very, very confusing. So this is going around a circle like this, you can imagine. And this coin is also going around a circle. As the disk is spinning, the coin is also going around a circle. Whenever there is a circular motion, you know that there is a centripetal force, which means as the disk spins faster and faster, the friction is what is making it to stick together with the disk. If you don't have enough friction, this coin will fly away. Just like as the car is turning to your left, you get pushed towards right because of the pseudo force. Similarly, I told you centripetal force is the actual force, centrifugal force is the pseudo force, so it will get pushed this way. So that means I need to calculate the frictional force and I need to calculate the centripetal force for each one. Why? Because centrifugal force is equal to centripetal force. So take it down. Centrifugal force is equal to centripetal force. Centripetal force is nothing but mv squared by r. mv squared by r can be written as mr omega squared. P is equal to r omega. So we have done this many times. So we should know this. For the 4 centimeter coin, for coin at 4 centimeter. By the way, omega, we talked about this in the last class. So omega is equal to 33. This one will be 100 by 3. (99 plus 1 is 100 by 3. For 1 revolution, it is 2 pi radians. For 1 minute is 60 seconds. So that means this will become radians per second. So that means mass of the coin is given as, oh, the mass is not given. Okay. Okay, mass of the coin, let's leave it as m. Radius is 4 centimeters, so 4 by 100. Omega squared is this entire thing square. So it means 100 by 3 into 2 pi divided by 60, the whole square. Okay. Similarly, I can do it for coin at 14 centimeter. Same mass, 14 centimeter. Omega is 100 by 3, 2 pi by 60. But what am I supposed to compare it with? I'm supposed to compare it with the friction. I told you the friction is what is holding the coin together with the disc. If the friction is not sufficient, if it is filled with oil or something, the coin will easily slip out of the disc. It will just fly out like this. So that means the frictional forces mu is 0.15. Mass is not given. Into G. G is approximately 10. So basically, I need to compare if this friction is more than this value or this value. So wherever the friction is more than this value, then the coin will stick around. Otherwise, the coin will fly away. So let's see, this is 14, this is 4. All the other things are same. So suppose if I calculate the 14 thing, or say 4, this is a smaller one. So it's supposed to be smaller. So let's try the 14th one. So 100 and 100 will cancel. So there will be 1. Pi squared, generally I take it as 10 approximately. So one of the 100 will cancel. So the remaining 100 will be there. 60 squared. So that 100, this 2 squares will be, 2 zeros will go away. So what is left is 3 squared is 9. 2 squared is 4. 6 squared is 36. Pi squared will become 10. 14. 100 would go away. Zeros will also go away. So this is what is remaining. So anybody quickly calculate this and tell me. 4, 9, 9, 81, 81, 14, How many times 81? 140 divided by 81. 140 divided by 81 would be
Sir, it has to be 4 into 100, right, sir? The 0 and 0 will get cancelled, sir. That last second step.
okay. Don't worry about my calculation. Tell me what you are getting here. Are you getting something close to this or not? Do it on your own method. Tell me whether
Sir,
you are
what did
getting.
you do, correct, sir? I got confused.
Okay, yeah. So now if I do this math, it will be 1.5 into m. So this is 1.72 m. So everyone listen carefully. The force on the coin for it to go around the circle is this much, whereas the friction available is only this much. So this is what is provided, and this is what is required. So required value is more than what is provided. So what will happen? What do you think? In this case, instead of 4, right? Instead of 14, we'll have 4. So you do the math, same math here. You'll be getting 4, 14, so 81, 40, 40 divided by 81. 40 divided by 81 will be approximately 0.5 m. So approximately 0.5 m. So here the centrifugal force or centripetal force is less than this, which means the coin will be going around the circle. Whereas here, this is more than what is provided. Everyone following? Anybody following? So if anybody is following, I can continue. Otherwise, I can stop here.
Sir, yes, sir.
Okay. So Saran sleeping. I see only
No, sir.
Chaitanya. Chaitanya responding. I don't know what happened to others. Maybe I should stop allowing some of the students for being regular. Catherine, are you there?
Yes, sir.
Tell me, what is the logic here? What are we talking about here? Which coin will fly away? Which coin is staying back inside? Tell me what we have done so far. What are we actually doing? Catherine, I'm talking to you. Are you there or not?
Yes, sir.
What is the difficulty? I not understood anything. Tell me what we have done here. That's very poor, Catherine. I thought you are a good student, studying properly. That means you are just, logging in and doing something else. Is that what you are doing?
No, sir.
Then I'm asking you just now, I'm teaching you, I have not even completed the problem. Can anyone else explain what are we actually trying to do here?
So there are 2 coins which are rotating on the disk, sir.
Okay.
So there should be a specific frictional force acting on the coin so that it keeps on rotating, sir.
Okay.
There we can see that for coin 2, the required force is more than the provided force, sir. So that the coin 2 will not be able to rotate on the disk forever since it's more, sir. Whereas the coin 4, coin at 4 centimeter will be at the disk, sir.
Okay, very good. That's all. So the force, centripetal force here is less, whereas the friction force is more, which means the friction is holding the coin together. Here, the centripetal force is more, and whereas the friction force is less, which means this will slip away. That's all. Is that so hard, Catherine? If you're not able to answer, it means you're not, focusing on the class. Very poor, very depressing. Okay, anyhow, in September, I'll be having classes in the center. So only people who are interested, you can come here. If you're not interested, you can stop coming. If you don't want to learn anything, you can stop. Because online class is very, very, depressing.
We starting the class from first, so
I will confirm. Okay.
okay, sir.
Yeah. So if anybody is going to give me some reason, sir, I'm very far away, this, that. Now, if you already talked to me, that's fine. But others, if you are in Coimbatore, you still have to come to the center. Okay. If you give me any excuses, then I'll ask you some, I'll give you a test and see how much you have studied on all these, online classes. That will tell your parents, how much you have been learning in this online class. Okay. It's very, very depressing, when students are not sincere in their classes. What happened to Veer? What are you doing today? Sleeping? Siddharth, Veer?
I just got my retainers changed, so I can't talk much.
What about you, Siddharth?
I'm here only, sir.
Is that such a very difficult problem? What are you thinking? Why you are not able to
No,
answer
sir.
anything? Very poor attitude. Okay, all of you. I see Elvin is answering a little bit, and then Chaitanya, that's all. And Saran, if I ask you, then you are answering. What happened to Kevin?
Sir, I'm there.
Kevin, Kirtan. Kirtan usually will answer what happened today. Not answering anything.
Sir, nothing. I just had some bleeding on my face. The pimples everything. It's bleeding badly. That's nothing else.
I don't understand you at all. I don't know what you're saying.
That's the pimples bursted. So
Okay.
it's just keep on bleeding, nothing. But I'm
Varsha.
focusing on your question, yeah.
Varsha, what happened to you? Are you there?
Yes, sir.
Why you are not able to answer anything? Whatever I'm teaching, I'm asking, and nobody is answering. These are all, additional exercise problems. It needs a little bit of thinking. If you don't understand, you have to open your mouth and, ask me the doubts. If you keep quiet, you're not going to learn anything. Deepika, what happened to you? Doing something else today?
No, sir.
Not heard you at all today. What happened to you?
Sir, I'm listening and listening.
Yeah, but I asked you a question after teaching this. I asked you a question. Did you answer that? Remember, I'm having a lot of, as you can see, I'm having a lot of health problems. And in spite of that, I'm trying to, without canceling the classes, I'm struggling to, take the classes. If you don't make use of it, we'll see. When you come to the center, we'll see, how many of you are really, proper sincere students. Okay, if you're not sincere, you'll be thrown out. Don't come here. Mithun?
Yes, sir.
What's your excuse? I'm teaching a problem and I'm asking a question. You're not answering. If you're not answering, forget about online classes. I'm not going to just for you. I'm not going to teach any online class. It's so stupid for me to keep on shouting here. Okay, I would like to close this meeting and go, but I think some 3 or 4 students are being sincere, so at least for them I will continue the class. Okay, just for their sake. Others, feel ashamed of yourself. Okay, wasting your time here. So don't try to do this in September. Okay. If you are not interested, you are, always welcome to leave the class. Okay, we talked about this cylindrical drum situation. So I showed you the theory concepts, the roundabout ride. So let's talk about that quickly. 70 kg man stands in contact against the inner wall of a hollow cylindrical drum. So that means there is a hollow cylindrical drum like this. So there is a man standing close to the wall. And then you know that this cylindrical drum will be spinning the roundabout rides. Radius is 3 meters. Rotating about its vertical axis. This is your vertical axis. 200 revolutions per minute. The coefficient of friction between the wall and its clothing is 0.15. So mu is between its clothes and the cylinder, it's 0.15. What is the minimum rotational speed of the cylinder to enable the man to remain stuck to the wall without falling when the floor is suddenly removed? So we talked about this, even if the floor is removed, he will still be sticking here. Why? Because the same concept, whenever the man is going around a circle, there is a centripetal force. So he is also, along with the cylinder, is also going around the circle. Whenever there is a circular motion, there is a centripetal force towards the center. But then when the car is taking turn towards your left, you are getting pushed towards the right, which means the centripetal force will be considered to be opposite to the centrifugal force. So this is centrifugal force. So this is your centripetal force. But you know that centrifugal force is equal to centripetal force.
So this is that type of question where you were asking if there was some theme park ride where it rotates and you get in the air, right? That type of question.
Yeah, even if the floor is removed, you will still be sticking inside here. So that's the question here. Read the question. What is the minimum speed so that this guy will be sticking here? 70 kg man. So that means it is m r omega square. So mass is 70 kg, radius is 3 meters, omega is 200 revolutions per minute, which means you have to multiply by 2 pi by 60 to convert it to omega, radians per second. So do this math. So that will be the force, and the friction is
So it will be 1,400 theta.
1,400
400
1,400
theta.
theta. What is theta here?
You can
Pi.
take, no, yeah, sorry, pi. I'm sorry.
Okay, you want to keep the pi as such. Okay.
Yeah.
Okay, so this is a required centripetal force or centrifugal force. Let's calculate the frictional force. So frictional force is going to be, in this particular case, I told you, the frictional force will be this way. So normal reaction will be this way. A friction, you will try to slide downwards.
So that's already given in the question, I believe, right?
Sir, the centripetal force is 4,400, not 1,400.
Yes, sir. Even I got the same, sir. 4,000.
Yes, sir. I got 4,400, sir.
4,400 Newton. Okay. Okay. So see how we can do this problem. So I calculated the centrifugal force, which means the normal reaction force is going to be in this way. And okay, so let me redraw this diagram one more time.
Sir, we'll have to put the weights in mg, and then we have to even find the limit, the limiting frictional force.
Yeah, that's correct. So the weight is pulling him downwards, whereas
So I believe that I guess the weight has to be less or equal to the frictional force required.
yeah. So the normal reaction force, right? This is your force towards the center. So that is your N. So the F friction will be mu into N. So what you calculated here is your N. So that means mu is friction is 0.15. Did they say 0.15? Yeah.
Yes, sir.
Yes, sir. It's given, sir.
0.15 into N, 4,400. Okay. Mg is, this is 70 kg into 9.8 or 10. So which means 700 Newton. So what is the mistake I'm doing? 200 vertical axis spinning. What is the minimum rotational speed of the cylinder? Okay.
Sir,
So that
686.
means,
Oh, sorry, sir.
what is 680?
No, sir. You multiply the weight with the gravitational constant. No, sir. I thought you took it as 9.2.
Okay. Yeah, you can. If you want accurate number, you can do it. No problem. So anybody got the answer here? 44 into 15?
660, sir.
660. So that means this force is more and this force is less, which means if you remove the floor here, right? If you remove the flooring here, what will happen? He will fall down, which means this 200 RPM is not sufficient. Okay, so that means they're asking you to find the minimum rotational speed. So that means do the same thing. Only thing now we don't know this value. You're not following what I'm saying? Yes, no? You're comparing this and this. So in this case, he will fall down. He will fall down if the flooring is removed. Which means you have to increase the speed of the cylinder. So if I increase the speed of the cylinder, it should be at least equal to this 700 Newton. Only then he will not be falling down.
Less than or equal to?
Yeah, more than or equal to, right?
Yeah, more than.
So this has to be more than this. If this is more, he will try to get slid upwards. So we don't have space here. So do the math here. So basically 700, so 0.15 into this value, 70 into 3 into I don't know this RPM, right? 200 RPM. So so I don't know the RPM, N minimum. RPM is 2 pi by 60 to convert it to omega. So that should be equal to 700 Newton. Or this should be more than or equal to. 100 meter. So do the math and find out the n. Anybody? Quickly do this. 70 and 70 cancels. One of the 10 is there. So 10 comes on this side. So divide by 10. So this will become 100. So 2 3s are 6. 6 goes away. So 10. 3, 5, 10 comes here. So 100. So this will become 100 by 0.15. 100 divided by 0.15. Minimum. 5 will also be here. 5 is approximately 3. So this will become 45. So 0.45.
Sir, it is not 100, sir, it is 10.
10, I brought this 0 over here. So this 10 and this 10 multiplication, it will become 100 here, right?
So on the left side, that the 0 near 70 and the 0 near 60, they both will get cancelled.
70 and 60. No, I cancelled. See, don't look at what I'm doing here. Do it yourself and tell me the answer. If you try to understand what I'm doing, I will not understand what you are doing, and you will not understand what I am doing. Simplification, you do it yourself and tell me the answer. So 0.5. So 0.5 is 1 by 2. So I think it will come around.
Sir, I'm getting 0.21.
0.21. What about multiplication by 100? To do that. I'm getting something close to 212.
Same here, sir.
Yes, sir. I got
212.3.
0.212. Yeah.
Okay.
Sir, I took pi value as 3.14, so I got 212.314.
Okay. So which means only if you're spinning above the speed, right, you will be able to safely remove the floor. Otherwise, what will happen is he will fall down. So this is the minimum speed. So n minimum has to be greater than 212. Any questions, anybody?
So what is the last word you've written after 212?
RPM, revolutions
Okay.
per minute.
Yes.
Because here I kept it as RPM because I did 2 pi by 60, right? So otherwise you have to calculate the omega first and then convert the omega to n minimum. But generally in our day-to-day life, we talk in terms of RPM. So if you see the table fan, it says 2000 RPM, 3000 RPM. If you see a water pump, it will say 5000 RPM, something like that. But in engineering terms or physics terms, we will talk in terms of radians per second. But for others, non-technical persons, RPM will make more sense. Okay, any questions, any doubts? Anybody? Okay, let's see. So I think we can do 1 or 2 more problems. With that, I'm going to say that this chapter we have spent enough time. I think we have spent at least 3 numerical classes, which is sufficient. So if anybody has some doubts, I can help. Otherwise, we'll go to the test in the next class. So Wednesday, so today is Wednesday, okay. So Friday. So Friday, what I'm thinking is Okay, I will give one extra day. Okay, Friday. So Monday you will have the test. Okay, so I'll give some assignment kind of thing. Then you can try that first, and then Monday we'll have the test.
Okay.
So I'm giving some extra time so that you can clarify the doubts, whatever you have. So make use of it properly. If you don't make use of it, you are not making use of my time properly. That's all I can say. Okay, let's see. 39, 40. Okay, 38 is also a very interesting question. Let's try 38. You may have seen in a circus a motorcyclist driving in a vertical loops inside a death well, a hollow spherical chamber with holes so the spectators can watch from outside. Explain clearly why the motorcyclist does not drop down when he is at the uppermost point with no support from below. What is the minimum speed required at the uppermost position to perform a vertical loop if the radius of the chamber is 25 meters? So they are talking about the death well like this. The
The
circus.
reaction is acting downwards,
Yeah, that's correct. So that means if I,
which includes the weight also. Yeah.
yeah. So imagine that this is a motorcycle. So when he is on the top, the motorcycle is somewhere like this. But still, this does not fall down. This will happen only when you have a minimum speed. Okay, otherwise it's possible that he will fall down just like the previous problems. You can try this in your home. What you can do is you can take a bucket of water or a small bucket of water, fill it up like this, and then you can start spinning it vertically. So
Yes,
initially,
sir, doing a loop, the water won't come outside, so it'll just stay inside.
yeah, that's correct. So initially you have to swing it a little bit to increase the speed. Once you have enough sufficient speed, if you swing it fully, it will make a vertical circle without the water coming down. And the easy way I understand this is when it is on the top, right? And the water is on the top, the water is like this. What's happening is just like you are, when the car is turning towards your left, you are getting pushed towards the right. So that means this is going around a circular motion, which means centripetal force is acting towards the center. Centrifugal force is acting the opposite direction because you are getting pushed towards the right. So that means the water is, having some kind of a pseudo force which is acting in the opposite direction. And that is why, it's sticking to the wall. It doesn't fall down. Okay, just like we are sticking towards to the car on the right side instead of going towards the left. Okay, let's try to understand this death well problem. Okay, if any of you are interested in doing this experiment, try this. Okay, maybe stand in your bathroom and do this. Okay, so that you don't spill out the water.
Yes, sir, I've tried it once.
Okay, if possible, get a video, send it to me. You can share it in the group.
Okay.
So,
I will try.
yeah. So in this position, right, if you see, the weight is acting downwards, mg. The reaction force is acting upwards towards the center. Okay, so here I'm going to say it as, that sigma F is equal to ma is the most important formula in mechanics. So R minus mg is equal to, but we are talking about circular motion, we are not talking about linear motion, which means mv squared by R. Okay, which means, let me call this as R1. This one will call it as R2. That means R1 R1 is equal to mv squared by r plus mg. I hope no doubts here, anybody? But if you take this one, mg is acting downwards because mg always weight acts always downwards. Since the reaction force is from the surface of the death well, right? That is also acting downwards. So this is a very interesting situation. So, but what I forgot to say here is, towards the center it is taken positive, away from the center it is taken negative. Okay, in the circular motion, towards the center positive, away from the center negative. So that means both are acting towards the center, which means R2 plus, so again the starting point is same, most important formula in mechanics, sigma F is equal to MA. So R2 plus mg is equal to mv squared by r. R is the radius of the death well. Okay, the small r. So R2 is equal to mv squared by r minus mg. So maybe I have not done this looping the loop concepts for you. Did we talk about looping the loop concepts? Maybe I have not done it. Okay, I think it's coming in the next chapter. So, but nothing wrong if we do a little bit of problem here itself, so that you feel comfortable. So if I come back to this equation, R2 plus mg is equal to mv squared by r. So they are asking me to find, let's read the question. Explain clearly why the motorcyclist does not drop down when he is at the uppermost point with no support below. So the explanation which we gave in this, it's the same thing. Okay, if you have enough speed, then the centrifugal force is equal to the centripetal force, which means this will make it stick to the surface here. Okay. It's a little bit hard to imagine, but if you again and again, I'm telling you, when the car is turning towards your left, you are getting pushed towards the right. So similarly, when you are trying to go around a circle like this, the centrifugal force will try to push it in the opposite direction. Okay, or according to inertia, right? You are trying to go straight, and that straight motion is what is pushing it towards the wall or towards the death well. So the concept here is, when you are at the topmost point, right, the reaction here will be 0, minimum speed to keep going around. So you can see that the reaction force is added to the weight, but what the weight cannot be made 0. To find the minimum speed here, right, this is the minimum speed, mv squared by r. So to find the minimum speed to go around the circle, I can make this as 0 because weight cannot be made as 0. So the reaction force, so take it down, R2 is equal to 0 for minimum speed to go around the vertical circle. Go around the circle, vertical circle, sometimes it's called looping the loop. Loop means circle, looping the loop means you are going around the circle.
Okay. The mg is equal to mv square by r.
Yeah, that's correct. Mg, so R2 becomes 0. So mg is equal to mb squared by r. So m cancels.
V square is equal to
This
GR.
is minimum speed, right? So v squared is equal to gr. Remember, this is minimum speed, which means this is v minimum.
Yeah, sir.
So v minimum is equal to square root of gr. So g is approximately 9.8 or 10. So r is 25 meters. So 10 into 25. So square root of 250. Yes, 5 into 3, approximately 15 something close to 15, I think. So what this means is
15.6, I think so.
15 point
15.811.
811. Okay, 15.8 is sufficient. So 15.8 meter per second is the minimum speed with which he has to drive. So if you have seen the circus, right? Initially, you will see that this guy will be going around in a smaller circles like this. Only when he has enough speed, then only he will go like this. Have you seen that? So initially, you have to gain some speed. Initially itself, the first round itself, he cannot go like this. The same thing here. Initially, you have to oscillate it until you gain some speed. Once you get enough speed, right, then you can try this full looping the loop. So that's a very important concept. So take it down properly. Okay, so your homework is to finish all the remaining problems, whichever you are not finished. I'm not going to do it again. Okay, so if any of you need some help, I'll help you. Otherwise, I'm not going to keep on asking. So if you're serious about your studies, do it. Otherwise, I can't do anything about it. So let's see. So I'm going to give some assignments. I'll send it to you, either PDF or online assignment. And we'll see how you're doing. Then Monday you will have the test. Okay. Again, it can be a PDF or it can be a online test. Most probably I'm trying to give
Monday, right?
Yeah.
Okay, sir.
So most probably I'm trying to give an online test to see, how you folks are performing.
So the online test is like MCQ, sir.
Say that again. Online test.
Online test is like MCQ form or
Yeah, it will be MCQs. Yeah. Because this particular chapter, theory, I'm sure all of you will study. Okay, it's not a big deal. Study something and memorize it and write it in the exam and get marks. Okay, anybody can do it. But understanding the problems, applying the concepts in the problems, that is what makes a big difference. Okay, so that is what will gain you to help you to gain more marks in your school exams and also in your entrance exams. That is what I am interested in. Make it a little bit difficult, not too difficult, so that you are improving yourself. Okay, so I'll be sending you an assignment. Okay, so and then get started with that. Finish all this NCERT problems, and then Monday you will have the test. Okay, thank you all. If you have doubts, you can stay back. Otherwise, bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.